Hi everybody, welcome to a new episode on my channel, the Dissenter. Today I have with me a very special guest. She is Dr. Patricia Churchland. I will just do a quick introduction to her. She is a Canadian-American philosopher, noted for her contributions to neurophilosophy and the philosophy of mind. She is UC President's Professor of Philosophy Emerita at the University of California, San Diego. In 2015, she was elected a Fellow of the American Academy of Arts and Sciences, and she's also the author of a number of books, including Neurophilosophy, Toward the Unified Science of the Mind-Brain, and Braintrust, What Neuroscience Tells Us About Morality. So, Dr. Churchland, thank you a lot for coming on the show.
It's a great pleasure.
Great. Okay, so I guess that we should start by giving a definition to people who don't know of what is neurophilosophy and what it adds to the philosophical picture in general, because we also have philosophy of mind. So what is it really about, and what's the difference there?
Well, when I began thinking about what you might call neurophilosophy, I had been at the University of Manitoba Medical School for some years, and I was tremendously impressed by what we were learning about the brain and how it had an impact on traditional philosophical questions. And I wasn't so much interested in the meaning of certain words, like the meaning of perception or the meaning of free will or the meaning of choice. I really wanted to know what those things really are for us. And that means you really need to know about the brain, because our decisions are made by the brain, our perceptions are all mediated by brain functions. And so it seemed to me that there were many features of developments and new discoveries in neuroscience that had a huge impact on traditional questions. What is the nature of knowledge? Well, since we were learning a great deal about the nature of memory and learning in the brain, it seemed to me quite obvious that you couldn't really do epistemology without taking into account what we already knew about the nature of the physical brain. Mm-hmm. So that was really the motivation for me. And I suppose in the larger scheme of kind of where philosophy was then, there was this really kind of odd tradition that had a lot to do with Jerry Fodor, but I don't really want to say he started it, but where the idea was that theory of mind, or how we think about the mind, the nature of cognitive psychology, should be independent of the brain. That it should be, as Jerry Fodor used to say, it should be autonomous with respect to neuroscience. And the first time I heard Jerry say that, I thought, this is just nuts. If the brain is the thing that does the thinking and the feeling and deciding and speaking, then of course you would not expect there to be a psychology that was independent of the brain. But a lot of people bought into that. And even Dan Dennett, who now thinks of himself as brain-friendly, for many, many years said there is the software and there is the hardware. And the software is the business of cognitive psychology and the hardware is the business of neuroscience, and they don't have to have anything to do with each other. And fortunately, I was sort of a stubborn person, and I was up in Canada, and I didn't give a crap what those guys said. And it just seemed to me to be dumb. And now I think, I don't mean to be rude, because it's very easy to make a mistake in science. I think it's very clear that the idea of an autonomous psychology was just really not productive. And where we are now in cognitive neuroscience is a long, long way from Jerry Fodor's idea of the autonomy of psychology.
Mm-hmm. Right. And it's interesting because at a certain point you refer there to the dichotomy between the hardware and the software. And in your book, Neurophilosophy, you spend a lot of time talking about the structure of the brain and the nervous system. So, is the structure of the brain itself, does it have sort of philosophical implications by itself, or is it only the functioning? I mean, is it important for us from a philosophical standpoint to know that it works on the basis of neurons and synapses and how it goes in terms of hormones and neurotransmitters and so on? Is that really important in terms of neurophilosophy, or does it just serve to ground all things in materialism, let's say?
No, that's a really good question. And I think the answer is that you really need to know the anatomy and the physiology of the brain. And the thing is that, and biologists have said this for a long, long time, that understanding function really is helped by understanding structure. Because out of an analysis and a description of structure, we have ideas about the nature of function. But I want to sort of do a sideways thing for a moment, and I want to tell you a story about a psychological phenomenon that we all know very well, and which we now know you can't understand or explain unless you know something not only about the brain, but about genes. So here's the story. As you know, there is a difference in efficiency of learning something, depending on whether you learn it at one long go or whether you break it up into batches. And we know that batch learning, work for a while, rest for a while, work for a while, rest for a while, means that you retain much more of what it is that you were trying to learn. So psychologists, and if you were a Jerry Fodor autonomy of psychology person, what you would try to do was to give a purely psychological explanation of that. What you would do, and psychologists did this, was they said, well, it must be because people get bored, or it might, people and animals, or it must be because your attention wanders. And you only have a certain amount of attention and you use it all up and then you don't have any left. And that's why learning in one go is less efficient. And people tested this at the psychological level and nobody really, and then it turns out that in order to learn something, there has to be a physical change in a neuron. There has to be, for example, a new synapse, or there has to be a new connection between one neuron and another. And as you know, when there is a change in structure, there has to be some proteins around. Proteins have to be made and put into the make that structure.
Sure.
Well, who makes proteins? Genes make proteins. So it turns out that there is a transcription factor called CREB. And CREB will turn on certain other genes that then make the proteins that then go into synapses. Now, that all takes time. And it turns out that once you've kind of used up all the available CREB and more has to be produced by the genes, you may as well just have a rest. And it turns out then that the reason why batch learning is more efficient has to do with the temporal dynamics of producing CREB acting on other genes to produce the protein that makes the changes in the neurons. And all of this stuff about, limitations on attention and so forth, maybe in some cases it plays some role. But the real story is one that you could not have got by any kind of philosophical analysis, You could not have got it by any sort of psychological experiment. It's a physical, structural feature. So I kind of like that example because it's very easy to understand. But of course, there are many other examples as well where we need to know about what it is about neurons that does something when, for example, we make a decision. And decision making is one of those areas now where we have learned a huge amount from animal models about the nature of decision making in neurons. That means you can't, as a philosopher, just go along and make it up. You have to know.
Yeah, that's really interesting because philosophers spent 2,000 years and even more than 2,000 years trying to come up with or discover how people knew things, how people knew the world, how people apprehended the world, right?
Yes.
And discussing about what was to be considered beautiful and what was to be considered true and so on. So, in a sense, neurophilosophy combined, let's say, with philosophy of mind, they both give ground to all of these other areas of philosophy, right? Like epistemology, ethics, aesthetics.
Well, that seems to me to be right. And you know, the person who really taught me that was long, long ago. That was Paul Churchland, my husband, who said, look, these are really scientific questions. We were just graduate students at the time. And he said, philosophy of mind should be a branch of philosophy of science. It shouldn't just be this thing where you get to make up thought experiments and could it be this and could it be that? And then, you know, philosophers are very fond of making up labels for themselves and putting ism at the end, you know, so I'm a X-ism or a Y-ism, or I'm a situationist, or I'm a this, I'm a that. And we sort of thought, what do they imagine they're doing? These are scientific questions. They aren't questions that you can just answer by making stuff up. And of course, the other point, and I think Paul was really important in teaching me this too, is that, and as was Quine, was that if you think that the current meaning of an expression is going to tell you something about the nature of the thing that refers to, you're kind of deluding yourself. It might tell you a little bit, but it's not going to tell you very much. And it might even be that the meaning of a certain word the word itself doesn't actually apply to anything. And it could be that certain expressions which seem to be useful for a while may turn out to change a lot as science develops. And of course, the great case in point really is gene, which, because nobody knew what a gene was, except that it was a carrier of information from parents to offspring. So gene was taken from a Greek word, and it had to do with the thing that makes stuff. And we didn't know what a gene was until about 1953, when we had the first real inkling. And that meant that the meaning of the word gene changed. You couldn't give a precise definition of gene beforehand. But by 1953, even though at that early point we couldn't really define it very exactly either, that opened the door to getting greater and greater precision in the meaning of the word. And I think the same thing is true of things like knowledge or belief or decision or free will, if you like. So many philosophers hate this because they don't want to have to learn stuff. They don't want to have to learn any science. They went through graduate school being told that all they had to do was read other philosophers. And unfortunately, they took that seriously. And so they hate the idea that they need to learn about brains.
Mhm. Yeah, and it's interesting now that you refer that because I didn't have these on my questions, but anyway, I now want to ask you that. You gave the example of the gene and how
Yeah,
it changed its meaning
yeah,
via the scientific process, let's say, because
yes,
because there are people, particularly people who aren't much into philosophy, let's say, that read something of that some philosopher wrote some time ago, and then they say, "Oh, he had some pretty good intuition about something scientific that we know now." And for example, there is that very good example of Democritus of Abdera
yeah, yeah.
that said something like, "Oh, the universe is just atoms
Atoms in the void. I know.
and the void and empty space, right?" But I mean, the notion he had of atoms didn't really correspond to the modern scientific notion we have
Yeah.
today, right?
No, but to give Democritus credit, I mean, I know we all love Democritus, of course, and I know you do too, but it was an astonishing thing to speculate that different substances are different, not because they have sort of intrinsically different natures, but because of the way the basic little bits of stuff are put together. And to think, well, gold is different from tin because the bits that make up gold are put together in a different way. And it was an important insight that I think hung around and hung around and hung around in science until experimental science had developed to a point where we could actually make it precise. And it is amazing. But then, the ancient Greeks, at least those who were naturalists, were astonishing. They truly were. And I include Aristotle in that. I mean, my God, what a visionary.
Yeah, Aristotle, we could say, was perhaps, well, I don't know if in other parts of the world there might have been someone who was close to that philosophical stance, let's say, but Aristotle, we could say that at least in the West was the first naturalist, right?
Yeah, I think that's true. And as you say, there may have been other people, for example, in India and in China, who had those ideas. I don't know as much about them, obviously. Although it's very interesting that on moral issues, Confucius and Aristotle are very close. They sound very similar to me. And so I think that was kind of an astonishing thing when I first actually realized that.
Yes, and now to move on perhaps to the epistemological implications that neurophilosophy has. Would you say that perhaps one intuition that was pretty close to what we know nowadays, to the knowledge we have, was that of Kant, when he said, for example, when he divided what existed, let's say, in terms of the phenomenon and the numenon, and he said that we could only have access to what he called the phenomenon because, and I'm saying this because it seems to me that what we know nowadays in terms of neuroscience is that we don't really see the world or experience the world as it is, but we only experience what our cognitive modules evolved to pay attention to, let's say.
Yeah, I don't know really how to get into that, if I may put it that way. I mean, for one thing, I could never make any sense of Kant's distinction between phenomena and noumena, and finally I gave up. It's very puzzling, and I thought, is this really a productive way for me to go here to, sort of bust my chops trying to understand, what this old guy meant when there was so much that he didn't have the first idea of. He didn't know anything about evolution. He didn't know anything about the brain. He didn't know much in the way of psychology. So 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 quite honestly, I don't know what he meant. Of course, that all of our perceptions and our knowledge are mediated by the brain, but the brain is an evolved organ, and it does pretty well in sort of addressing the unobservable, or at least those things that we can't observe. I mean, who actually observes a strange quark? I mean, you can observe the effects of quarks or neutrinos or what have you. Do I get metaphysically very excited about the fact that I can't directly observe, a quark or a neutrino? No, actually, I don't. I mean, there's a lot of things I can get very excited about. But the fact that nobody has ever seen or may ever see with the naked eye, I'm sure they won't ever see with the naked eye a neutrino, doesn't make any difference to me. I mean, that seems to me to be not very interesting, if you know what I mean. Whereas, I mean, the idea of quantum entanglement, or that there are these things that we think of as neutrinos, that's pretty interesting. But the fact that I can't actually observe one with unaided doesn't interest me very much at all. Big deal. I mean, I can't see very much without my glasses either, so big deal.
Okay, right. And would you say that because nowadays we know, particularly from evolutionary biology, evolutionary psychology, and neuroscience and so on, that we have this sort of cognitive modules that, in a sense, have some a priori knowledge of the world, because we have structures of the brain that are specialized to deal with certain specific problems, and so they are prepared to do that beforehand.
Who says that? Who says that? Who says that? That we have brain modules that are a priori structured to do certain things.
Oh,
I mean,
the a priori part, it's mine. I put it just to ask you if what we know nowadays about the way our brain functions and the problems we are evolutionarily prepared to deal with, if we could talk about if you could talk about a priori knowledge like some more ancient philosophers did.
Well, first of all, it remains really puzzling in neuroscience exactly how the brain is organized. And normally, of course, it's true that at the back of your brain you have the visual cortex, and that's what's really important when you do visual perception. But it's not like it's hardwired for that. And we know that for a number of reasons. Here's one really interesting one. If you are born blind and you learn to read Braille, and you're put in a scanner while you're reading Braille, functional magnetic resonance imaging, what part of the brain do you think is going to be super important for reading Braille? Now, I would have said the somatosensory cortex up here, and I would have been wrong. It's the visual cortex. Mm-hmm. Why? Well, probably because for perceptual cortex, the biggest part and the part that carries, as it were, the highest degree of sophisticated processing is visual cortex. So when you have a really complex problem and your visual cortex is not doing anything, it does that problem. Now, what does that mean if you have this idea that there are these cognitive modules that solve particular problems? Like Tuvey and Cosmody still think that there is a cortical module for solving the problem of detecting cheaters. There is no reason that I can see in neuroscience to believe that that's true. So from a psychological point of view, they find that an agreeable idea. And maybe it will turn out that the brain has such a module, but there's no real reason to think that it does. And so I want to go back to a point I made earlier, which is that there's so much we still profoundly do not understand about how the brain codes information and how the brain is organized. And the modularity thesis, of at least of the kind that Jerry Fodor was fond of, has really taken a beating. It does not look like it's very plausible. Granted, in a mature individual whose sensory apparatus is all normal, the visual cortex processes visual information. But that may be owed not to a priori knowledge in any sense at all, but just because given the input and given the statistics of the input into the visual cortex is the best thing to handle that. And so there is a school of thought, and I don't want to say we know this, but there is a school of thought whereby it's very plausible that it's the statistics of the input that determine whether or not you see versus feel versus hear and so forth. So the auditory cortex is auditory because of the statistics of the input that come in through the auditory nerve. It's not because, some Fodorian god said, thou shalt be an auditory module. And we kind of don't know about so-called higher functions, things that the frontal cortex does. We know in mature individuals that frontal structures are important in decision-making and inhibiting undesired responses and so forth. But we really don't, the idea that there is a module for voluntary choice, for example, is not neurobiologically plausible at this point, which isn't to say we know what is plausible. There are many, many unanswered questions in neuroscience, and I'm quite happy to be patient as opposed to making stuff up. I'd prefer to be patient and let the data come in and then be guided by the data than just say, oh, yes, we know there's got to be cognitive modules right there above the eye that handle such things as social cognition. Yeah, nobody knows that.
Mm-hmm. Yes, but just to try to be fair to Dr. Cosmides, because I already had her on the show. And
Good.
And I asked her specifically about if the cognitive modules she and Dr. Tooby and others talked about would correspond to something that is very particularly physic in the brain. And I asked her if it would be something in the connectome or some specific region or area in the brain, and what she answered was that she was not really particularly interested in trying to locate the modules in the brain, and she even said that she wasn't trying to do any sort of phrenology here, So perhaps what I understood she meant by cognitive module is that there's some sort of combinatorial operations that the brain does in order to try to solve the problems we learn to solve throughout our evolutionary history, something like that.
Well, we know that the brain is a big problem solver, but okay, so here's an example that puzzles me if we think about, we know that Homo erectus, about at least 1.5 million years ago, made boats. All right? And we know that just about every hunter-gatherer group that lives anywhere near a body of water makes a boat. And it might be kayaks, or canoes, or rafts, or all kinds of stuff. Is there a boat-making module? Probably not. There's probably all kinds of problem solving in a practical context. But the fact that Homo erectus and Homo neanderthalis, as well as us guys, we Homo sapiens, have made boats, and probably maybe even before Homo erectus, for all I know, doesn't mean that there is a boat-making cognitive module. I mean, almost certainly there is no boat-making module at the neurobiological level. But what we really don't know is how neurobiology, our brains, solve those kinds of problems about making a boat. And there's no real reason to think that as boat building became better and better, you know, as you went from rafts, say, to canoes to and so forth, that somehow there were evolutionary changes in the brain that made this a priori knowledge, or made this knowledge get built in. There's not the slightest reason to think that. So I would prefer myself to sort of wait until we have a much deeper understanding of the nature of problem solving. And rather than sort of advance the idea that there are cognitive modules and that when somebody has a particular kind of problem, the problem is with their cognitive module. I mean, bear in mind that people used to say this with regard to dyslexia. And one of the really profoundly important discoveries in neuroscience was made by a neuroscientist, Paula Talal. And what Talal found was that unless there are other kinds of frank neurological damage, if a child is dyslexic, it's not because their reading module is busted. It's because in regions we don't really know, but somewhere in the auditory system, they have a difficulty processing high temporal, features that come in a very fast temporal sequence. If you slow things down, then they're usually able to do the processing. So it didn't have anything specific to do with reading at all. It just manifested itself first in spoken language. And because the spoken language wasn't functioning as it needed to, they couldn't process phonemes fast enough, it manifested itself in written language. So, but there were certainly people who argued at the time, oh yeah, there's a reading module. But, you know, reading's only been around 5,000 years. So how could the brain has not evolved significantly in the cognitive domain in the last 5,000 years, probably not in the last couple of 100,000 years. It's evolved. I mean, we've evolved in terms of digestive enzymes and a few other things, but your brain is much like the brain of somebody, or at least at birth, would be like the brain of a Homo sapiens baby born 300,000 years ago. So yeah, maybe there are cognitive modules, but the case is very weak at this point.
Mm-hmm. Yes, but just another thing about that, and then we will move on to another topic. That is, of course, we also have culture and cultural evolution, and I also already talked with Dr. Robert Boyd, for example, that is one of the leading figures in terms of cultural evolution.
Yeah.
And so that's pretty clear that, for example, to build a boat, we couldn't simply do it based on some a priori knowledge, let's say. We have to have other things, particularly things that are transmitted by culture through the generations, right? But I don't want to put words in your mouth, but aren't you thinking about cognitive modules in terms of them being sort of encapsulated as Jerry Fodor put them? Because when I talked with Dr. Cosmidis, she even said that she was a bit frustrated because of the way Jerry Fodor presented modularity back in the 80s or something, because she and Dr. Tooby didn't really ever thought about modules in terms of them being isolated entities, but that they could combine with each other, for example.
Mm-hmm, mm-hmm. Yeah, then I'm just a little puzzled about what constitutes a module. I mean, what does a psychological phenomenon have to be in order to be called a cognitive module?
Mm-hmm.
I mean,
Yeah.
if boat building isn't a cognitive module, why is cheater detection a cognitive module? And a lot of folks are not very good at cheater detection. I mean, I just watched this amazing documentary about the Bhagwan Rajneesh, and here were these thousands of people who sort of gave all kinds of money and were dressed in a funny way in order to. And there were lots of people with college degrees and so forth who joined this cult, and he was just a con man. And I thought, if there are cheater detection modules, what's going on with these folks? People are conned all the time. You have to really, you have to be conned a few times, and then you learn, and you think, oh boy, I'm not going to let that happen again. And kids are regularly instructed by their parents not to be conned. I don't think cheater detection is one of the things that comes so naturally to people at all. And that's why we are very easily conned. We can be cheated on all the time. We don't want to talk about current politics, but there are commentators who talk about the current political atmosphere in the United States in terms of con men and so forth. So hey, a cheater detection module? Maybe there's a few people who have it, but there's a heck of a lot of us who don't have one.
Mm-hmm. Right. Okay, so I guess we will leave this issue perhaps to another day or to other people, just to move forward, because I have other topics I want to discuss with you. And the next one is, of course, one of the major topics of philosophy of mind, that is consciousness. So we have the easy problems and the hard problems of consciousness, right? The easy problems are basically explaining our ability to discriminate, integrate information, reporting mental states, and so on, and knowing, for example, the particular areas in the brain that process each of those kinds of information. But then we have a very complicated thing that even there are people that think that it will never be, science will never be able to solve it. That is the hard problem. That is to trying to explain the phenomenology part of consciousness, right? And how we acquire, for example, how we have the experience of taste and color and things like that. So what would you have to say about that?
Well, it is a prediction to say that science will never understand it. And it's some of the most scientifically naive people, like Colin McGinn, who've said that. So I'm thinking, that's a pretty strong prediction. Why would I believe Colin McGinn? And maybe the prediction is correct, but it's also a fact that there have been many, many predictions about what science could never explain, right? And Francis Crick was fond of telling us that there were people who would say, you'll never explain the nature of living, what it is to be a living thing, because of course it involves élan vital, and science will never explain it. Now, there are still things we don't entirely understand about the nature of metabolism or the nature of gene regulation and so forth, but there's an awful lot we do understand. So much so that you'd be hard put to it to find somebody now who'd say you'll never understand the nature of what it is to be alive. So I don't know. I mean, scientists or philosophers who don't know very much, making a prediction about what science will and won't discover strikes me as hilarious. On the other hand, it's also the case that there are some scientists who have made similar kinds of predictions. But again, these are predictions. And so, why should I take it seriously? But the sort of real point, I think, is that what do they think that should be the upshot of this prediction? Should it be that we shouldn't even try? Should it be that we shouldn't try to find out how anesthesia works, for example? Should it be that we shouldn't try to find out how sensory integration works? Or, I mean, what do they think we shouldn't do anymore? That we're wasting our time if consciousness can never be explained? I mean, there's a big difference between being in deep sleep and not, in terms of consciousness. Is Colin McGinn telling us that we don't need to bother understanding that because it'll never be explained? I mean, I'd really like to know what that difference is. And moreover, as I'm sure you're aware, a lot of progress has been made in understanding the difference between being in deep sleep, being in dreaming sleep, and being awake. And some of those differences are highly relevant to the idea of sensory integration and the experience of phenomena like touch and smell and vision and so forth. So I mean, one of the people who used to say, it's the hard problem is Christoph Koch, but it's very interesting that Christoph now, largely because of the effect of Tononi, thinks that we can actually make an awful lot of progress and that there's no point in stopping until you're sure you can't go any further. And of course, you can never be sure you can't go any further. All you could say is, I'm stumped. But that doesn't mean some wonderful graduate student is going to be stumped. That wonderful graduate student might figure it out. So it seems to me that insofar as it's a project worth getting to the bottom of, that it's important to understand the role of, for example, the interlaminar nuclei in the thalamus. Why do I pick that? Because we know that for people who have been in coma for a very long time, like in one case, 7 years, but whose cortex and other structures are still intact, if you stimulate the interlaminar nuclei of the thalamus, they wake up. They're conscious again. They come out of coma. That's a pretty amazing result. That's owed to Nick Schiff at the Cornell Weill Medical School in New York. That's a very important result. Does Colin McGinn think it's uninteresting? I can't imagine he thinks it's uninteresting. And it's certainly relevant to beginning to explain the nature of consciousness. So that's kind of my response is, look, it's some of these guys like McGinn in particular have sort of made their reputation by saying these rather extraordinary things. Like it makes them sound like they're really smart, that they know we'll never explain consciousness. Well, I mean, really, that's silly. It is. It's just silly. I mean, I can't take something like that seriously.
Yeah, and then on the other hand, we have people that are working a lot on trying to understand how consciousness works, and I have specifically to talk about this because he is also my compatriot, that is António Damásio, right?
Yes, yeah. He is. Yes, he is.
Yeah, right.
Yeah.
So, and he has this hierarchy of stages of consciousness, right? He starts with and I'm going to talk a little bit about this now just for the audience, that he starts with the proto-self, that is kind of the most basic level of awareness, and that is integrated, it's kind of integrating all the emotions that are produced by the body at the level of the hypothalamus, the brainstem, the insular cortex, and I think those are the three main areas. And then he moves on and adds a sort of another layer to it, that is core consciousness. That is when emotions develop into feelings. And we also share a lot of this with some animals, or a lot of them even. And then he adds a third layer, let's say, that he calls extended consciousness, and this is exclusive to humans, that requires conventional memory and allows for the development of the autobiographical self. So do you think that this work that Damásio and others are doing gives us a good promise of us being able to completely understand how consciousness builds from the periphery of the body, because this includes the way the rest of the body processes information to create emotions, and then builds up from that, from there until the really higher processes that occur in the brain?
You know, it's an interesting question. I was never quite sure in his organizational picture why the emotions had a more basic role than, say, other forms of perception. I was also never quite sure why he thought that the emotions represent states of the body. I mean, I know that there is some relationship between the periphery, you know, touches on the skin and so forth, but I think there may be some updating from Ralph Adolphs and I'm sorry, I'm forgetting the name of his co-author on the emotions, but I think the emotions are an extremely important part of the story, but I don't know. I mean, maybe it'll end up being a very productive framework. I'm not sure that I can quite get my mind around how that is at the moment. But yeah, I don't know. I don't really know what to say about that.
But is your issue specifically with the part about emotions, or aren't you in general a big fan of, for example, embodied cognition?
Gosh, well, I mean, the thing about the embodied cognition story is that there are some things about it that make a lot of sense, and there are some things that kind of, you know, are an exaggeration of what makes sense to me. These are big deep issues, and I don't really want to get into a whole sort of discussion about what I think is unhelpful, shall we say, about the embodied cognition story. I mean, obviously, if I didn't have a body, or if parts of my body were very different from how they are, then, you know, yeah. But I mean, part of what, for me, I think fails to really grip me in the Damásio story is its neurobiological mechanisms. I mean, it's a kind of story that is more, I don't know whether this is accurate or not, but it seems more psychological than it is neurobiological. And I think when people are talking about explaining consciousness, what we'd really like to have is a neurobiological account of mechanisms, such that we can understand, say, the difference between being in deep sleep and not. And the idea that there's core consciousness, well, I mean, I don't know, maybe there is, maybe there isn't. I think it might be a useful start. It might be a useful way of organizing the data that are there. But I mean, you have to, I mean, these are, one's take on scientific hypotheses is sometimes quite personal. And I'm a bit of a stubborn person. I'm a sort of a tough customer. That is, I don't like to just jump on a bandwagon and off we go. And partly because there have been so many bandwagons that people have jumped on and then they've ended up going in exactly the wrong direction. And so I tend to be a little bit skeptical. And it's not because I have a personal thing about the author of an idea, so much as that I just kind of want to reserve judgment unless the data are clear and compelling. And I don't see in the Damásio story that we have clear and compelling data yet. Maybe they will come, and, but I don't see it yet. And I'm not the only one who is sort of taking a wait-and-see attitude amongst neuroscientists. Yeah.
Mm-hmm. Right, that's fair enough. And as you might have already noticed, I only like to pose easy questions, right?
Yeah. No, I know. No, these are very difficult, and it's important that we have all kinds of ideas about how things work. But it's also important. I mean, Francis Crick used to say, it's really important not to fall in love with your idea, not to fall in love with your theory. And so I mean, maybe that affected me in the sense that I don't like to fall in love with just anybody's theory because they've got a story about, levels of something or other, levels of consciousness, or well, how do you know there's only 3? How do you know there's not 20? How do you know that there's not just 1? And that what's below the level of consciousness isn't really part of consciousness at all. I mean, that's what Bernie Bars would say. That's probably what I would say. If it's not in consciousness, why call it lower level consciousness? Why don't you just say you're not conscious of that stuff? But, as I said, it's good that there are people who are willing to theorize. But it's also important that we don't get too excited about the theories until, they've really got solid evidence on their behalf.
Mm-hmm. Yeah, on my side, I have to be patriotic here, otherwise people won't like what I'm doing.
Yes, so. I know that he is held in great regard, and he's been an old friend for a very long time. And I'm very frank with him when I disagree with him, which he doesn't always like, but that's okay too.
Okay, great. So now I guess another easy question. That is, from a scientific/neuroscientific point of view, is it plausible to talk about a self in terms of the human mind, or how the human mind works?
Yeah, I mean, I think that when we use the expression of self, that there are actually many functions involved. I mean, some have to do with awareness of the body, some have to do with autobiographical memory, some have to do with recognizing your current state of emotion or mood, or metacognition, where you know that what temperamentally that you're like, or what personality features you have. Those, you might say, are all part of self. But, there's a sense in which, of course, Hume was right. That is, that there isn't a single thing, either in the brain or, if you like, in the mind, that is the self. And I don't know whether António Damásio thinks that there is or not. I think that he thinks that it's multidimensional. But why he thinks it's tied to consciousness, I'm not quite sure, because some aspects of those of the self, namely a sense of body position, for example, sense of balance, sense of whether you're hungry or thirsty. Probably lots of animals who may not be conscious actually have those. But what is the kind of self that gives consciousness? Well, John Searle seemed to think that Damásio was saying it's the kind that gives consciousness. Oops. So Searle accused him of a kind of circularity. And and it's hard to sort of dispel the idea that there is no circularity involved there, that his understanding of how it is that the notion of a self gives rise to consciousness without having already being conscious, self-conscious. It's a puzzle how that's supposed to go, and I'm sure he will explain that.
Mm-hmm. Okay, and this was specifically a central theme of one of your books, that is. So we know that there are very specific areas of the brain that are pretty well mapped, I think, that process moral emotions and moral sentiment. So in what ways is this important to understand morality? That is, is it just to explain the biological basis for our evolved morality, or should we also use that information to inform a moral system?
It's a really interesting question, and I suppose it's part of both, but I mean, on the one hand, of course, as having the scientific bent, I've always thought that it's important to find things out for their own sake. And whatever practical value might come, you might not be able to envisage. And again, if I may refer to Crick, I mean, he was fond of saying they had no idea whether there would ever be any practical outcome of understanding the helical structure of DNA. And he said they certainly had no thought that it might ever be used for forensic purposes. So that's part of it. But on the other hand, of course, I also sort of think that it's important for people to understand that even though they may have feelings of great certainty with regard to their ideological convictions or their moral convictions, that there is a biological basis for this. And that disagreements between individuals may obtain, not because one is stupid and the other is wise, although that could be. It might help to understand that there can be biological reasons for this. And so in my new book, one of the things that I am concerned about are those features of our biology that help us understand why there can be significant differences between individuals in what their conscience tells them, even if they grow up in the same family. And I think if we understand that, maybe it will help us negotiate in a more practical way with people with whom we disagree. I mean, it's sometimes very satisfying to see the opposition as just a bunch of numbskulls. But on the other hand, if we have to live together and we have to negotiate solutions to problems, it's probably better that we don't indulge ourselves in those things. I think, for example, it's really important for us to try to understand the nature of between-group hostility. What's that really all about? Some of it you can sort of understand, but a lot of it is just deeply puzzling. And so there are things that I think science can teach us about that and about other aspects of aggression, for example, things that we really don't yet understand at all, that might be helpful as we live in what is an increasingly dangerous and frightening world. So I do think that there can be a practical outcome. I like to think that it would be an outcome that would be for the good. And that would be my hope. But I wouldn't let that hope sort of color my understanding of the nature of the discoveries themselves, if you see what I mean. I think it's really important to be as objective as you possibly can. Now, I know that we all still have our biases and our backgrounds and our experiences and our temperaments and so forth. But you can still try to be as objective as possible. And when we do have to get along with people with whom we have tremendous disagreements, it is really important not to think that somehow God told us what the right thing to do is, and those guys are just heretics. And that has been in the West a kind of long tradition. And it's caused a lot of trouble, actually, as history documents only too clearly. And the person who's a great hero of mine from the very beginning of the time I did any philosophy is Socrates. You think, oh, Socrates, he never wrote anything and he just kind of stumbles along. But, on moral matters, that was where he really was incredibly wise. And what worried him always was that there were con men who would take advantage and manipulate others, and that we would delude ourselves into thinking that our feelings of certainty gave us the right to do terrible things. And I think on both of those points, Socrates, bless him, he hit the nail on the head. And those are still issues now. And those are social, practical issues of life, and not necessarily issues where science has anything additional to tell us, except that it's very unwise to allow yourself to be conned, and it's very unwise to allow your feelings of certainty to cause you to do catastrophically awful things.
Mm-hmm. Right. And do you think that if neuroscience ever is to prove definitely that through genetics, through influences coming from genetics and the environment, there is not really something that we can call free will, that all that happens in our brains and our actions that come from that are 100% determined, that we should still keep the notion of free will and personal responsibility just for the sake of the good functioning of human society?
Well, we already know, of course, that the genes don't determine every aspect of our behavior. So that isn't really a realistic thing to wonder about. We know that there is such a thing as self-control, and we know that kids can be taught self-control, that some people find it easier to learn self-control than others, just like some rats find it easier to learn self-control than others. And we have some idea of the mechanisms, but only a very, very slim idea at this point, but we will acquire more. And we are learning about the nature of decision-making. We know that individuals don't just pay attention to the consequences, but in fact, decision-making is a constraint satisfaction procedure. And that there are many constraints at many different time scales, and that past memories are important and current perceptions are important, evaluation of the consequences, values are important in all that. This is why, utilitarianism is really a kind of confusion, because it says basically there should only be one constraint. It's evaluation of the consequences. And that's not how decision making actually works. And that's not how good decision making actually works. So I think as we understand more about that, there's obviously a place for holding people responsible for actions that they took. I mean, consider Bernie Madoff, who ran a Ponzi scheme worth billions of dollars. He ran it for over 20 years. Now, you can't really say that was, genetically programmed. I mean, that's pretty tough. But of course you should hold him responsible. And
yes, but sorry, just to interrupt you there, but if someone is to say that by including the environmental inputs, the brain, by the way it is structured, can only process those specific inputs in that predetermined way, let's say.
Well, it's just to say that if there's a causal explanation, then the person didn't have self-control, and that's just false. Mm-hmm. There can be a causal explanation even when you have a tremendous amount of self-control, as in the Bernie Madoff case. So some people have this idea that if an action has causal antecedents, it can't genuinely be free. Where the hell did that come from? It came from Descartes. Well, geez, I mean, come on. Hume knew that was nuts. And he said there are different kinds of causes that are relevant to determining whether an action was voluntary or not. So that, for example, if you accidentally fell and knocked over a torch that set the barn on fire, then you caused it all right, but we don't hold you responsible for it. It wasn't voluntary. So there were causes, but there are other kinds of causes, the ones that are internal, where, you have certain beliefs and certain goals and certain aims, and you go ahead and you run a Ponzi scheme for 20 years. And it's unrealistic to think that we can hold nobody responsible and everything would be just tickety-boo. I mean, humans are not like that. So it isn't an option. Mm-hmm. You can't dismantle the criminal justice system. You can modify it in certain ways, and it is being modified all the time. But you can't just say, well, hey, people are caused to do what they do, so let them all go. Open the doors, open the prison doors. I mean, we know what happens when you do that.
Mm-hmm. Exactly. But would you say that from trying to put it in a purely neuroscientific perspective, would you say that the reason why we don't hold other animals personally accountable would be that in the case of humans we have the most developed prefrontal cortex that allows us to have agency and to think and rationalize before we perform a specific action.
But we think animals do that too. Even rodents can do that. Even rodents have self-control. They can defer gratification. They can stop an action once started. They can predict the consequences of an action and suppress the action if they think that it's not desirable. And they use frontal structures plus the reward system plus the hippocampus in order to do that. And we do hold animals responsible. If my dog, jumps up on the table and helps himself to the steak, she gets punished, and then she doesn't do it again. Do I put her? Do I let her call a lawyer and put her in jail or something? No. But of course we do. And that's part of what goes into animal training. But, we train each other all the time, too. Somebody will do something really unfortunate or thoughtless, and if they get called out on it, then they're apt not to do it again. especially in a small community. I mean, we live in a very small community in the summer, and people are acutely aware of how their actions will impact other people because they don't want to acquire a reputation for causing people misery or for being thoughtless or doing things that are considered antisocial. People are acutely aware of these things because they don't like to be punished. And there are many, many subtle, small ways, even in a small community, of punishing people. They cease to be welcomed. They're shunned. Things don't work out quite so well for them when they're trying to find a contractor and so forth. Look, these things happen all the time. It's only when something is a really big, major thing that because we're a large community, we have these big social institutions like a criminal justice system. But hunter-gatherers managed extremely well. Otherwise, you and I wouldn't be here. They managed their social affairs very well, and it often involved, small kinds of punishment. Sometimes they had to get rid of people. The anthropologist Franz Boas amongst the Inuit, for example, have stories about how they thought about what to do and considered talking to other people and finally realized that, this man was a sort of compulsive murderer and he had to be executed. And they did it. So, I think I think it's a bit odd in a way to say we're the only ones with a really highly developed frontal cortex. I don't know. The more I learn about rodents, the more impressed I am with what they can do. But poor old Jerry Fodor, if I may malign him once more, I mean, he used to say humans are the only ones that can think. For all of the rest of the animals, it's just reflex. Mm. And it is so deeply, dazzlingly wrong. Our brains are so similar to the brains of every other mammal. We have more neurons, but we got all the same stuff, all the same neurotransmitters. They got a hippocampus, we got a hippocampus. They have frontal structures, we have frontal structures. Yes, ours is bigger, but, we don't have any unique structure that we know of. And anatomists, have looked fairly hard. Now, it doesn't mean it's not there at a more, refined level that we haven't been able to see anatomically. That's possible. But, and humans can do lots of things that animals can't do. But maybe that's just because we have hands.
Yeah, right. Those are very interesting ideas there. And where do you think that the discussion between reductionism and emergentism is really useful from a scientific point of view? Because there are people who say that that it is pretty clear that in the future we will be able to explain the structure of the universe down to the subatomic level in all detail, and then that it is only a matter of scaling up or scaling down from subatomic particles to atoms to molecules to the brain, to psychology, to economy, and politics, and all of those things. And then there are the side of people who defend emergentism. But what I get from them is that they believe that there will always be some kind of spooky thing going around there that people will never be able to explain. But do you think that those extreme positions, let's say, are really useful to talk about these things, these scientific issues?
Well, one question to ask in that context is, what difference would it make to my scientific enterprise or my philosophical enterprise to adopt one or the other? Would it matter? Would it make any difference at all? Or is this just, the kind of conversation we have in a bar after we've had about 4 beers? Really? See, I can't see why making a choice one way or the other would make the slightest difference to anything that I'm learning sort of every day about the nature of the brain. So if somebody can show me why it would really change my scientific behavior, I might be interested. But if this is just kind of, metaphysical bullshitting, then I think, well, okay, there's a time and place for that. And it's usually late at night after, a hard day's work where you're in the bar. But quite honestly, it doesn't affect the way I think about anything. I'm going to take every scientific discovery seriously. There's a lot of scientific speculations I don't take seriously because they're just speculations. They're people spouting off, sometimes because they don't want to do the hard work of actually doing the science. It's easier and cheaper and faster to just, put out a speculation and write a speculative book. And I don't actually want to waste my money on that. And I don't want to waste my time with it. But maybe that's because I'm old. I mean, maybe if one is younger, speculating about these things is really fun. I just find it a waste of time.
Okay, I just wanted to ask you because I've been recently through a series of videos that only recently I came about. I didn't know it even existed on YouTube, that of a 3-day workshop put up organized by Sean Carroll with 10 or 12 people called Moving Naturalism Forward or something like that.
Right.
And it's really incredible how through 10 sessions of an hour and a half each, people can go on and on and on.
I know, it is interesting. I mean, can't they play golf? Can't they play tennis? Yeah, I mean, why are they doing this? I don't know. There's lots of things to do. Why would you want to sit around and listen to someone, talk about crap coming out of his head? I don't know.
Well, I did it, so I guess I will keep quiet about that.
Well, that might be your job, though, you see, given that you have this program and that you have a blog and so forth. You probably have to listen to it and see what these guys are up to. But I have the luxury of knowing these people and thinking, I think I really need to go fishing today.
But I have to be honest. Sometimes I also ask myself that, and even about the people that are there throughout like 15 hours talking about those things.
I mean, I think one thing is really interesting about brain development, and that is that even identical twins don't end up with identical brains. Yeah. And that's because there's a lot of kind of micro decisions that are made where this neuron branching in just this way and that neuron branching in just that way, that mean that the end result is that the brains are a little bit different at birth. And then, of course, they can get more different as a result of experiences. So when we talk about explaining in great detail what a person's going to do or think or say or what have you, you have to kind of remember that there is this practical problem of finding out what all the neurons are doing. And functional MR is not going to tell you that, needless to say. We don't have any technology that can. If you don't mind my putting in microelectrodes all over your brain, maybe we could make some progress, but I don't think you really would do that. And I wouldn't do it to you. So for really interesting practical reasons, both having to do with the technology, but also having to do with ethics, we may get general explanations of the go of the thing, ones that we don't have right now. But to get a highly detailed explanation of exactly what you're going to do, millisecond by millisecond. I think at the moment it looks very unlikely.
Mm-hmm. And do you think that if someday, of course we already live in a highly developed scientific world, but in an even more developed world in the future in terms of science, do you think that there's any risk of philosophy becoming obsolete or redundant?
Well, it depends on what questions they're asking. If the question is how to make consequentialism work, then I think it's doomed. If the question is how does spooky stuff work so that I think, then I think it's doomed. But if the question is different, if it's a question about the nature of problem solving, for example, and how to synthesize what we know at a neurobiological level and what we know at a psychological level, then I think there's real work to be done. But you can't do epistemology anymore by pretending that we don't know anything about how the brain knows things and how the brain imagines things. We know rats imagine a route through the maze or a route to food because we can record from the hippocampus while they do it. So hippocampal knowledge of spatial things and where reward is and so forth may be much more important to understanding knowledge in general than, some book about, I don't know what epistemologists write about anymore, but about necessary truths across all possible worlds. I mean, oh my God. If you really want to understand how an evolved structure like a brain and works, then it really matters that you take the data seriously. But if you just want to make it up, then by all means go make it up, but don't expect me to take it seriously.
Mm-hmm. And is it a plausible question to question about what are the implications of the knowledge we acquire from neuroscience and the fact that we are completely material beings? What implications does it have to the meaning of life from a human perspective?
Well, I think those sorts of questions have always been asked, regardless of how you think about things. I mean, and here I really find Owen Flanagan's discussions of the Asian philosophers very interesting, because here are Confucius and Mencius, who there was no provision in their scheme of things for a divine power, no God. So there was no God that was somehow the source of moral laws. They didn't even think that moral laws were what it was all about. They thought it was about the virtues. And they did ask questions about the meaning of life that they gave as good answers to as most people today give. I mean, when Dr. Phil is asked these sorts of things on television, he says the same old thing that people have been saying for thousands of years. The meaning of life has to do with love and family and meaningful work and making a difference to your community. And what lives on is the difference that you make to your family and your community. What lives on is not some spooky little thing that zips on up to some, other place. So I think those questions, I mean, obviously they're questions that all of us ponder about, like, what's the point of it all? And the answer is there is no point of it all. We are biological organisms. And then you think, there is a way to revel in the fact that we are all biological organisms, that we have this wonderful kind of connectivity to everything that has a nervous system. But not just that, but to everything else as well. And so I don't know, that the connectivity to biology, and the fact that, you know, I can look at a whale out in my bay fishing and think, you know, your brain, you have a lot of brain there. It's the same as mine, just the same. And I find that very moving. Not everybody does, and I don't always every day, but sometimes I do. And being a biological organism and really kind of reveling in my biology is kind of a cool thing.
Mm-hmm. Yes, I was just asking because this is a question that comes up very frequently when we talk about naturalism and materialism, because most people that are not really intellectually or philosophically minded, let's say, worry a lot about these things, right?
Yes, of course. And I think it's entirely reasonable. And I think, you know, the answer that people have given for thousands of years, namely it's love and life and work and family and connectedness and the good that you do. And that's all that lives on. And yes, when you are alive, you love life and you want to live it to its fullest. But then, you know, part of being a biological organism is that what you can leave behind is the good work that you did. There isn't anything else. Mm-hmm. Or the bad that you did.
Yeah, sure. Yeah, sure. And I would personally say that even the fact that we get to know through science and neuroscience and all the scientific disciplines that all that these things that we think about, love and all the moral sentiments and on, are grounded in reality, it sort of gives meaning to them.
It does. I mean, to me it does. But I realize that it's not true for everybody. And that's partly why I wrote the book Touching a Nerve, was that I realized that I had lots of friends and especially students who would say, you know, if you think that you're just the brain, and doesn't that freak you out? And it really doesn't. But then, I mean, maybe it's just that I've been thinking about it like that for so long. But the other side of it is, as I said, that I find it very easy to revel in my biologicalness and to feel that I have this special connectivity with all biological things. Which isn't to say I get goofy about it. I do kill a wasp, you know. I don't like wasps. I was stung by one the other day, and doggone it. So it's not like I, you know, get silly about it. But the sense of connectivity is what grounds me. Yeah.
Mm-hmm. Okay, great. So I would say that's a very good note to end on this interview. So, Dr. Churchland, just before we end this, would you like perhaps to share with people where they can follow your work on the internet, perhaps the social media where you're active or not? And I don't know if you're perhaps working on a new book you would like to share with people or not.
I do have a new book that has just been sent off to the publisher. It's called Conscience, the Heart of the Brain. I have a website called patriciachurchland.com. I don't use Twitter very much, and I almost never use Facebook. But occasionally there'll be something that I'll send out on Twitter, and my Twitter is @PatChurchland. So, but thank you for asking, and it's been a pleasure.
Yeah, it's also been a pleasure to talk with you, and again I would really like to thank you for taking the time to be here with us today. It was really a very pleasant and informative conversation, and I really love your book and your
Oh,
work.
good. Thank you. Thank you so much, Ricardo.
Hi everybody, thank you for coming to my channel and for watching this interview until the end. As you might have noticed, I've started this channel last February and have been putting out regular interviews with academics and intellectuals from a variety of fields. To keep the channel sustainable, I would like to ask you to please visit my Patreon page and to consider making a pledge. Any amount, even $1, would already be a great help. Otherwise, if you like what I'm doing, please share it, leave a like and hit the subscription button. I would also like to give a huge thank you to my patrons, Karen Litske, Anne Blanchett and Per Helge Larsen. Thank you for all.